Now that we have looked at what the sigma notation is, let's take a look at some of its properties. Now the first one is very useful. Now the first one says if you want to sum bracket UR plus minus UV, then you can actually consider it as the sum of the difference of these two separate series. Meaning, if you have summation R times R plus 2, then if you multiply the R in, you can actually get summation R squared plus 2R. Now this is the sum of two separate sequences of numbers. Alright, the first one you can call it UR, the second one you can call it VR, then this becomes this. And then what we are trying to say here is you can consider this entire sum as the sum of two separate series. The proof is very easy. The proof is just this. You want to sum UR plus VR. You put all the U's together and put all the V's together. Then this is just summation UR and summation VR. Done. Now it's important to note that while you can do this for plus and minus, you cannot do it for times and divide. Meaning this, in general, it's not true that summation UR VR is the same as summation UR times summation VR. If you look at the same example, summation R plus 2 is not the same as summation R times summation R plus 2. If you look at part 2, summation UR divided by VR is not the same, again I highlight, not the same as summation UR divided by summation VR. So a simple example is the one given here. If you want to sum R over R plus 1, it is not the same as summation R divided by summation R plus 1. You cannot distribute the summation sign like this. Now the second property is very easy to understand also. If you have summation, some constant C times UR, then what this property is trying to tell you is that the C, the constant, can be brought out. Okay, see, the C has gone out. Now again, the proof is very easy to understand. If you have summation CUR, it's the same as CUM plus CUM plus 1 until the last term CUN. And because C is a common term, we can take out this common term. And then this remaining piece here is just summation UR. Done. So very simple examples are shown here. You want to sum from 1 to 33, 3R is the same as taking the 3 out. So you have 3, summation from 1 to 33, R. For B, okay, it's similar. This time, the thing that we want to highlight is R is the number that's changing, n plus 1 is a constant. So because it's a constant, you can take the n plus 1 out. Note that you cannot take the R out. R is not a constant, so the R has to stay inside the summation symbol. This is out. Now let's take a look at property number 3. Now this is a property that you will use quite often. Now you want to sum, this time, a constant. Now the formula says, or rather the property says that this is C times n minus m plus 1. Now why is this so? I think it's easiest if we use the examples A and B to explain this. Now if I want to sum 3 from the lower limit r equals to 1 to 20, now what does this mean? This means I will put 1 in, I will put 2 in, I will put 3 in, until I put 20 in. Now notice that each of the numbers are all 3. Now this is because when you put a number into 3, there's nothing to substitute r with. There's no r there. So when r is 1, it is 3. When r is 2, it is also 3. So altogether, you sum 3 20 times. So what does this mean? This means the sum is just 3 times 20. There, 3 times 20, and that's 60. Now I will use B to explain this idea again. Now B says you want to sum 5 from 1 to n. This time you have an upper limit n. Now remember, n is a constant. Now this means what? This means I put 1 in, I get 5. I put 2 in, I get 5. I put 3 in, I get 5. And then I put n in, finally, I also get 5. Then I ask myself, how many terms are there here? There are altogether n. So it means the sum is just n times 5. Easy, right? Now let's take a look at C and D. Now, if you look at C, now C looks a little bit complicating, but it's actually not. Because remember, n is a constant. The only non-constant here, the only thing that's changing is your r. So I look at my lower limit, that's n plus 1. I look at my upper limit, that's 2n. So I look at the n square here. N square is a constant. So I'll tell myself, I put n plus 1 inside n square, I get n square. I put n plus 2 inside n square, I also get n square. Again, remember, there's no r. So I would keep on doing it until I sub in the upper limit 2n inside n square. Again, there's no r, so I'll get n square. Then I ask myself, now how many terms are there here? They are all together upper limit minus the lower limit plus 1 terms. So that's why you see this line. N square multiplied by the number of terms. So you get n squared times n cubed. Done. Can you try D on your own? Okay, let me help you start if you have problems. Now remember, I will tell myself 5a is a constant. There's no r there. So this is the same as my lower limit is 12, my upper limit is 30. I'll take 12 and I'll sub it inside here. I get 5a. I take 13, I sub it inside the same thing. I get 5a. 14, also 5a. Until the last term, 30, also 5a. So how many terms are there here? Upper limit is 30, lower limit is 12, plus 1. Okay, so altogether, 5a multiplied by 30 minus 12 plus 1, and that gives you 95a. Done.